Okay, so here's problem number 2. Problem number 2 is about this kite. So we have this kite that's flying in the air, okay? And we said that this distance right here was 8, right? And then I'm saying that z is going to be the length of the string. And let's call this h, okay? Now, in your the last slide on the Desmos, when this problem was introduced to you, we talked about the things that are changing. The length of the string is changing, and the height of the kite is changing. Okay, so the way this question reads, it says the kite is rising vertically at a constant speed of 2 meters per second from a location on the ground. Let z be the length of the string. Find the rate of change of the length of the string when the string is 10 meters long. So our first step is always to draw a picture and kind of put some variables down, and then I like to do, what do I know? Okay, so what do I know? What am I given? What rate am I given here? And it tells me that the height of the kite is rising vertically at 2 meters per second. So I know that dh dt is equal to 2. And if you want to put meters per second there, you can. Okay, so I know that dh dt is equal to 2. Okay, what do I want to know? What's the problem asking me to find? It's asking me to find a specific rate. It's saying find the rate of change in length of the string. Well, z represents the length of the string, so the rate of change of that is going to be dz dt. And when do I want to know that? There's always a when. When do I want it? When do I want dz dt? I want it when the length of the string is 10. So that's how I write that. I know this, I want this, and I want it when z equals 10. Okay, so that's our first step. Well, that's actually our second step. Second and third, actually. So our first step is to draw a picture and assign some variables. Then, what do we know? What do we want to know? And when do we want it? Okay, next step is to find some equation that relates these variables. Okay, so like what's an equation here that relates z and h? Okay, well, hopefully you're saying the Pythagorean theorem. So let's say that h squared plus h squared equals z squared. Does everybody agree with that? Okay. Now, the next step is going to be differentiate this equation, okay, with respect to t, okay? And I don't have to solve this equation for any particular variable. I can just differentiate this using implicit differentiation, or the chain rule, however you want to think about it, okay? So if I differentiate this equation with respect to t, the derivative of 8's not changing. If you think about it, in the picture, 8's not changing, so its derivative would be 0. I mean, this dude is standing right here. He's not moving anywhere, right? He's got the kite. He's just standing there. He's not running along with the kite like some crazy kid. He's just standing there. So what's the derivative of 8? That's 0. What's the derivative of h squared with respect to t? Okay, well, you take the derivative of h squared with respect to h, which is 2h, and then you multiply by dh dt. Now you might see why, when we did implicit differentiation, why I liked to just use dy dx instead of y prime. Okay. Now on the right side, what's the derivative of what's the derivative of z squared with respect to t? It's 2z times dz dt. Okay. So now we have this relationship that we've differentiated, okay, and then this is the same thing. We either want to substitute and then solve, or solve and then substitute. The last one, I think it was already solved, so I substituted first. So this time I'm going to solve first. So go back to what is it that I want. I want dz dt when z equals 10, correct? So I'm going to solve this equation right here for dz dt. So dz dt is going to equal h times dh dt divided by z. Okay? I canceled the 2's there. All right? So now I need dz dt when z equals 10. means I got to plug in z equals 10, right? Okay. And I also know dH dt is 2. Uh-oh. I don't know h. I don't know h. I know z is 10, or that's when I want it. I know dH dt is a constant 2, but what am I going to plug in for h? There's a relationship between h and z. So you've got to go back to your original relationship, or you got to go back to your picture and say, what is h when z equals 10? What is h when z equals 10? So you say, well, h squared plus h squared equals 10 squared. And hopefully you're saying, oh, Mr. Minder, that's 6. Yes, it is. It's 6. Okay? So you might have, your answer, or when you solve for the variable that you want, might involve other variables that aren't over here. So you might have to go and figure out what those are. Okay, so we got 6 times 2 is 12 divided by 10, or sorry, 6 times 2 is 12 divided by 10, which looks to me like 1.2 is dz dt when z equals 10. And more importantly, 1.2, what are the units on that? Because we want to make sure we have the units. The units are important here. Because these are rates. They're describing rates of change of quantities. We should be able to put units on these things, right? So what are the units of z? Meters, right? And what are the units of t? Seconds, right? So this would be meters per second. Okay? So that's example number 2. And stick around, we'll do the next 2.